Dear students, welcome to EPG Pathshala. Today in this module, we will be discussing about landfill gas management. Now, landfill are nothing but an engineered structure where your waste is disposed of or stored in a safe manner. You can also call it as the containment of waste in a secured area where you protect them from contaminating the air, water, soil and the surrounding environment. Landfills, based on the type of waste that is being contained, they are classified into two types. One is your sanitary landfill and the other one is your secure landfill. Now, sanitary landfills are preferred for your municipal solid waste and the secure landfill are preferred for your hazardous waste, where for a secure landfill you provide more level of protection for the waste. Now, during the landfill process, the waste gets degraded, especially when the municipal solid waste, they get degraded when they are disposed or stored off in a landfill. During the process of degradation, it generates landfill gas and leachate. Now, leachate is a watery liquid that oozes out from the waste material depending upon the moisture level present in the waste. Now, during the degradation process, where different phases of degradation occurs starting from your aerobic phase and your anaerobic phase, during the process it results in the generation of different types of gases. The major gas is methane. This is generally termed as your landfill gas. Now, this module we will discuss about how or what is a landfill gas, how it is being generated, how it will migrate and what are the different treatment options that are available for the landfill gas. Now, with this introduction, now let us look into the learning objectives of this module. The learning objectives of this module would be to know the composition and the characteristic of landfill gas, to understand the mechanism of landfill gas generation, to study or know the different stages of bacterial decomposition that leads to gas generation, and to understand various conditions that favor or affect the landfill gas generation and migration. Then we will understand the migration of landfill gas and the factors influencing them. Then we will study about the landfill gas collection and the treatment options available. Now, as I told you earlier, solid waste, especially municipal solid waste, is ultimately disposed of into a land which does not have any protection, and this is generally called as an open dump. In older times, the waste was simply collected and then just piled up on the ground in heaps. This is called as open dumps. Now, the open dumps had caused a lot of undesirable consequences and it has adversely affected the human health and environment. So, that is when the sanitary landfills actually came into existence. Now, sanitary landfill happens to be improved and a secured method for the disposal of solid waste. Now, once they are disposed in landfill, they undergo a lot of reactions starting from your physical, chemical and biological reactions. The organic substance that is present in the landfill will undergo biological degradation and it will lead to the generation and release of leachate and gases. The biological reactions occurring in the landfill will always depend upon the moisture content, waste composition, temperature, oxygen availability, the presence of microflora, compaction rate and many more. Now, let us see what is a landfill gas. The waste that is contained in the landfill, they might undergo a lot of reactions and they result in the generation of a mixture of different types of gases. Now, it is a product of methanogenesis and it consists of methane, carbon dioxide with a minor concentration of nitrogen, carbon monoxide, oxygen, ammonia, sulfides, hydrogen and non-methane organic compounds like your trichloroethylene, benzene and vinyl chloride. Now, the process of biological degradation of organic matter will release landfill gas in the landfill and it is affected by a number of factors like your temperature, moisture, waste composition and so on. Now, this table shows you the composition of landfill gas, where you can see methane contributes a major proportion, followed by carbon dioxide which is 33.6%, then you have oxygen of about 0.1, nitrogen 2.4, hydrogen 0.05%, carbon monoxide, ethane in the range of 0.01 to 0.05, you have also a generation of other gases like ethene, acetaldehyde, propane, butane, helium, etc. Other compounds that are present in the gases include your unsaturated hydrocarbons, halogenated compounds, hydrogen sulfide, organosulfur compounds, alcohols and so on. Now, let us look into the generation of landfill gas. Now, landfill gas is generally produced by three different processes. One is your microbial decomposition, volatilization and chemical reaction. In microbial decomposition, the organic waste is mediated by microorganisms present in the waste material or which occurs naturally or from the soil, which is used as a cover or a liner material. Now, the biological degradation of organic waste material, they occur in different stages and the composition of gases changes accordingly in every stage. Now, volatilization is the second process where non-methane organic compounds are generated. The third type of process is your chemical reaction, where the chemicals present in the landfills react and generate gases. For example, ammonia and chlorine react to generate a harmful gas. Now, this table provides the landfill gas that is generated by various biodegradable components of waste. For example, if you see cellulose, that generates about 829 meter cube per ton of waste. It is both carbon dioxide and methane put together. Among this, 50% is carbon dioxide and 50% is methane. Protein generates around 988 meter cube per ton of biogas, and this is 48.5% carbon dioxide and 51.5% methane. Likewise, you can have a fat. Fat generates the highest amount of biogas, which is around 1430 meter cube per ton, but here the carbon dioxide proportion is less and the methane proportion is high of around 71.4%. Now, let us look into the various stages of bacterial decomposition in landfill. The organic components of the waste are degraded by microorganisms in the landfill. Three broad biological groups are present in organic portion of the waste. One is your protein, which is a large complex organic material and is composed of hundreds or thousands of amino acid groups. The carbohydrate, which consists of cellulose, starch and sugars, is the second type, and the third one is the lipids and fats. All the different stages may be progressing simultaneously until all the waste reaches stage 5 and stabilization occurs. Here again same process takes place in different stages, like first is your aerobic degradation, then it is followed by an anaerobic degradation. Now, stage 1 is the hydrolysis or aerobic degradation. Now, hydrolysis or aerobic degradation stage occurs in the presence of oxygen. This stage occurs when the waste is placed immediately in the landfill, and it depends upon the availability of oxygen in the trapped air within the waste. The aerobic microorganism will metabolize the available oxygen and it will degrade the organic fraction into hydrocarbons, carbon dioxide, water and heat. The heat will tend to rise and the temperature reaches up to 70 to 90 degrees Celsius. Now, the compacted waste has a lower temperature due to the lower availability of oxygen. The water and carbon dioxide react to form carbonic acid, thereby increasing the acidity of the leachate. This stage would last for few days or weeks depending upon the availability of oxygen. From this stage, your anaerobic degradation takes place. The stage 2 is hydrolysis and fermentation, where the depletion of oxygen occurs in the waste. Now, your facultative anaerobes starts establishing themselves and they cannot tolerate oxygen, and the carbohydrate, proteins and lipids are further hydrolyzed to sugars, which are then decomposed to carbon dioxide, hydrogen, ammonia and organic acids. Likewise, the protein undergoes decomposition by deamination and they produce ammonia and carboxylic acids and carbon dioxide. Now, the leachate generated at this phase will be rich in ammoniacal nitrogen. The organic acids, namely the acetic acid, propionic acid, butyric acid, lactic acid and formic acid, they are formed depending upon the composition of your waste material. The temperature in the landfall will drop to between 30 and 50 degrees Celsius during this stage, and the gas concentration reaches up to 80% of carbon dioxide and 20% of nitrogen. Stage 3 is acetogenesis phase, where the organic acids are converted by acetogen microorganisms to acetic acid, carbon dioxide and hydrogen. Now, hydrogen and carbon dioxide level continue to decrease. Once it decreases, then your methanogenic bacteria starts establishing themselves, which will result in the production of methane and carbon dioxide. The acidic condition in this stage will increase the solubility of metals, which can be analyzed in your leachate. Chloride, ammonia and phosphate ions are also found to be in higher concentration in the leachate. The presence of organic acids generate a very high acidic levels in the leachate, and the pH level will range between 4 or even less. Now, this is the main stage for landfill gas generation. I mean the last phase where around 60% methane and 40% carbon dioxide is generated. It is generally a slow process and it takes many years for completion of anaerobic oxygen depleted environment. There are two classes of microorganisms which are active in methanogenic stage. One is mesophilic bacteria, which operates between 30 to 35, and the other one is thermophilic bacteria, which is active between 45 to 65 degrees Celsius. When the top temperature drops below 15 degrees Celsius, then the rate of biological activity drops drastically. The pH also plays an important role, and especially for methanogenic bacteria, and the pH range should be in the range of 6.8 to 7.5 for their establishment. Now, this phase is longest, but may not commence till 6 months to several years. The last stage is stage 5 or the oxidation stage. The final stage of waste degradation is oxidation. Once again, the anaerobic bacteria will evade out and new aerobic microorganisms will start establishing themselves in the waste pile. Now, aerobic microorganisms now convert the residual methane to carbon dioxide and water. Now, this image shows the various phases of degradation within the landfill. Now, stage 1 is your aerobic degradation or hydrolysis, which results in the production of carbon dioxide and water. From stage 2, your anaerobic process takes over. Now, stage 2 is your hydrolysis and fermentation phase, where your organic acids and ammoniacal nitrogen is produced, and stage 3 is your acetogenesis, where acetic acid, hydrogen and carbon dioxide is produced. Stage 4, where methanogenesis occurs, resulting in the formation of methane and carbon dioxide. At the end of stage 4, your aerobic organisms starts establishing themselves again, and this is called as oxidation stage or stage 5, where the residual methane is further converted into carbon dioxide and water. Now, this image will show you the gas production within the landfill during the different stages, stage 1, stage 2, stage 3, stage 4 and stage 5. For example, if you see the nitrogen, the molecular nitrogen which is high in stage 1 slowly drops in stage 2 and it comes down in stage 3, and it establishes once again at the end of stage 4 and peaks out in stage 5. Likewise, if you talk about methane, the production of methane is observed at the end of stage 2 and it is there continuously till the end of stage 4. Carbon dioxide, which is high in stage 2, drops down, comes down, it is gradually decreasing, and then at the end of stage 5 it drops down. Oxygen, you find it in stage 1 where it is slowly dropping down, and in stage 5 it is slowly picking up. Now, let us discuss about the various conditions that affect the landfill gas production. One is your waste composition. As the amount of our organic waste increases, the quantity of landfill gas also increases. In case of increased amount of chemicals, then the generation of non-methane organic compounds are accelerated through the process of volatilization or any other chemical reaction. Now, age of refuse, the waste, if it is more than 10 years old, then less amount of landfill gas is produced when compared to a newly buried waste. The amount of landfill gas is generated between 5 to 7 years. Presence of oxygen in the landfill. Now, oxygen generally inhibits the methane formation. The methane production generally occurs under strict anaerobic conditions in the landfill. Moisture content. The presence of moisture is one important factor that influences your process. Now, the presence of moisture generally promotes certain chemical reactions which help in gas production. The microbial degradation is again enhanced in the presence of moisture, leading to increased landfill gas production. Temperature is another important factor where the microbial activity is generally accelerated with increase in temperature in a landfill. Higher temperature also causes volatilization and other chemical reactions which generate more amount of landfill gas. Now let us discuss about the various characteristics of a landfill gas. First is the density and viscosity. The quantity of an individual gas determines the concentration of landfill gas. For example, a mixture of 90% carbon dioxide and 10% hydrogen produced in the first stage of anaerobic process will be heavier when compared to air, while a mixture of 40% carbon dioxide and 60% methane which is produced during the methanogenic stage will be slightly lighter when compared to air. Next is your heating value. The heating value of the landfill gas is around 500 BTU per feet cube during methanogenic phase, which is half that of natural landfill gas. The actual heating value of landfill gas is dependent on the age of the waste and the type of landfill cover. The next characteristic is your non-methane organic compound. If a landfill comprises a significant amount of municipal solid waste, the landfill gas produced will contain 50% methane, 50% carbon dioxide and some amount of non-methane organic compound. The concentration of non-methane organic compound in landfill ranges from 200 to 15,000 parts per million or ppm. The next characteristic of the landfill gas is water vapor. The landfill gas generated during the decomposition of waste generally contain 4 to 7% by volume water vapor. The quantity of water vapor in landfill gas is function of temperature and pressure inside the landfill. Temperature are typically elevated over ambient during biological decomposition, increasing the evaporation of water into the LFG or the landfill gas. Other characteristics include hydrogen, which is produced during waste decomposition, particularly during the initial anaerobic conversion of mixed organic waste to acetic acid. A significant amount of hydrogen is later consumed in the formation of methane. Now hydrogen is flammable between 4% and 74% by volume in air. The presence of carbon dioxide affects these ranges, although little significant change occurs near the lower limit of the range. Now let us discuss about the landfill gas migration. The gas produced in the landfill does not remain idle. It keeps migrating from one place to another depending upon the availability of the void spaces, pore spaces within the refuse, soil covering the landfill. Methane is a lighter gas than air and hence it travels vertically upwards and breaches the surface of the landfill. However, the upward movement of gas is generally hindered by the overlying compacted waste or the cover material. Now during such conditions, then the air moves horizontally to find weak areas through which it can escape or move upwards. Always gases use materials of least resistance to travel across, namely sand or gravel. Now carbon dioxide generally is collected in the subsurface due to density differences. Migration of gas is governed by various factors, that is the direction, speed and the distance of movement is generally governed by various factors. First one is the diffusion. The landfill gas moves and spreads to the surrounding area through the process of diffusion. Second characteristics or the second factor is the pressure. Now pressure plays an important role in migration of landfill gas. High pressure is created in areas of landfill where gas accumulation or gas concentration is high. Accumulation generally occurs due to compaction of overlying waste. Variation in pressure will result in the movement of gas from high to low pressure areas. Increase in gas concentration will increase the subsurface pressure, which tends to be higher than the atmospheric pressure, leading to release of gas to the atmosphere. Temperature is another important factor. When temperature increases, gas diffusion and the rate of migration also increases. Now frozen soil over the landfill may act as a physical barrier for the upward movement of landfill gas. Landfill cover type and permeability will also influence the gas migration. Material used in landfill cover will influence the migration of gas greatly. Higher the permeability, more easy would be the migration of gas. Now sand and gravel are more permeable than clay and silt. Also natural and cultural pathway influence your gas migration, like your natural geology and man-made structures like the fractures, faults, fractured rocks, porous rocks in natural geological features that influences the migration of gas. Likewise drains, trenches, vents, pipelines and tunnels, which are man-made structures, also act as a channel for gas movement. Now, wind direction and speed also influences your gas migration, because wind carries the landfill gas and mixes the gas with air. Now, moisture plays a role when the gas accumulated within the pores are pushed out by rainwater. Wet soil in the cover does not allow gas to escape from the surface. The groundwater levels also play a role or influence the gas migration. Now, gas migration is greatly influenced by variation in groundwater table below the landfill. When the water table rises, the gas moves automatically upwards. Now, let us discuss about the various landfill collection methods. Now, landfill gas control systems include collection, conveyance and treatment. An ideal collection system consists of a sequence of gas collection wells which are positioned throughout the landfill. The gas collection wells are designed based on the volume and density of waste, depth of waste, area of landfill. Now, the collection wells in the landfill offer pathways for the passage of gas. The landfill gas is either discharged directly to the atmosphere or they are collected and further treated depending upon the potential of causing health and environmental risk to the local area. Now, under the gas collection system, you have two types of gas collection system. One is the passive gas collection system and the other one is the active gas collection system. Now, passive gas collection systems are generally established either during active operation or after the closure of landfill. Now, collection wells or extraction wells are used in passive system for the gas collection. The collection wells are generally made of perforated plastic material which is then mounted vertically throughout the landfill up to a depth of about 50% to 90% of landfill waste thickness. If there is groundwater within the waste, the wells are terminated at the groundwater table. Now, a passive collection system may also contain horizontal wells to facilitate passage of gas through the landfill. Now, these horizontal wells will be more suitable for landfills that need to recuperate gas rapidly. Now, gas can be controlled with the help of liners on the top, on sides as well as at the bottom. An impermeable liner trap the landfill gas and is used to generate ideal gas passage pathways. The efficiency of a passive gas collection system will always depend on the way the gas is controlled and on the environmental conditions. When pressure is not sufficient enough to drive the gas to the control venting device, the passive systems will generally fail to eliminate the landfill gas efficiently. In case of high pressure, outside air enters into the landfill through passive vents which do not direct gas to control devices. Therefore, these passive collection systems are not consistent enough in areas where you have high risk of gas migration. The second type of system is your active gas collection. These are considered to be most effective for landfill gas collection. Now, it consists of both vertical and horizontal gas collection wells which is analogous to a passive collection system. Now, unlike a passive collection system, the active collection system includes valves to control gas flow and to provide a sampling port. Now, active collection system includes vacuums or pumps which help to push gases out of the landfill. The gas migrates in the direction of low pressure. Now, let us discuss about the various landfill gas treatment methods. There are three basic methods for landfill gas treatment. One is your combustion methods or combustion technology, non-combustion technology and odor control technology. Under combustion technologies, it comprises of flares, incinerators, boils, gas turbines and internal combustion engines which thermally degrade the substance that is present in the landfill gas. In a combustion technique, methane is converted into carbon dioxide resulting in the reduction of risk of large amount of gas emissions. Now, combustion or flaring technique is considered to be most efficient in landfill gas that consists of a minimum of 20% methane. When the concentration of methane is less than 20% by volume, then a supplemental fuel such as natural gas is required. But when you use natural gas, it becomes expensive to be operated. There are two types of flares which are used in combustion technology. One is your open and the other one is enclosed flares. Now, open flame flares Here it comes with a pipe through which the gas is impelled. It consists of a pilot light for igniting the gas alongside the regulation of the gas flow pathway. Now, this technology is easy to use. Now, this technology is easy to be used because of their simplicity in design and operation. However, the disadvantage of this technique will include inefficient combustion, difficulties in monitoring and the aesthetic problem. In an enclosed flame flare, which is more expensive and complex, it contains a number of multiple burners which has within a fire resistant wall which encloses the flame. Now, it is capable of controlling the amount of incoming gas which is contrasting to the open flame flares. Now, this makes the combustion more consistent and proficient. Other enclosed combustion systems such as the gas turbines, boilers, process heaters and internal combustion engines are also used efficiently to eliminate the organic compounds present in the landfill gas. In addition to this, these techniques help in generating useful electricity. Next is a non-combustion technology. They are again of two types, one energy recovery technologies, two gas to product conversion technologies. The landfill gas is directly converted into energy in energy recovery technologies, where they are converted into commercial products like CNG, methanol, purified carbon dioxide and methane, or LPG or LNG, which is liquefied natural gas, in gas to product conversion technologies. Now, landfill gas has to be pre-treated to remove impurities like the non-methane organic compounds, water and carbon dioxide before subjecting it to non-combustion technologies. The next type of treatment technology is the odor control technology. It helps in preventing odor causing gases to escape from the landfill. The top cover restricts the odor that is generated from the newly deposited waste, which release the landfill gases produced during the biological decomposition. Now, extensive covers are used as landfill top cover to restrict the moisture from leaching the waste and promoting bacterial growth and decomposition. Now, planting vegetation on the landfill cover can also decrease the odor. The process also helps in eliminating odor from the landfill gas by combusting the odor causing gases thermally. Now, venting of landfill gas with the help of filter can also be utilized to minimize the odor. Now, let us discuss about what are the beneficial uses of the collected gas. One, it can be widely applied for energy use. It can help in conserving other energy resources. They provide economic benefits to the people, decrease the risk of global climate change, used on site by using a boiler or any other type of combustion system which provides heat. With the help of micro turbines, steam turbines or fuel cells, electricity can also be generated on site. The landfill gas can be collected and sold off site through natural gas pipelines. They can also be used for evaporating the leachate produced as a byproduct of the reactions occurring in the landfill. To summarize, at the end of this module, we have studied about what is landfill gas, how it is generated. We have discussed about the composition of landfill gas, their characteristics, their heating value, etc. Then we discussed about what are the different factors that are influencing the landfill gas generation. Then we discussed about what is migration, how the landfill gas migrates vertically upwards and horizontally throughout the landfill, and how it escapes the vents were discussed. Then we also discussed about the various waste collection systems, which is the passive waste collection system and the active waste collection system. Lastly, we discussed about the various treatment technologies which are available for the landfill gas, which is your combustion technology, non-combustion technology and odor control technologies. Finally, we discussed about how or what are the advantages of using this landfill gas as a fuel. I hope this module would be of help to you. Thank you.